Hi friends! Today we are going to discuss a very interesting topic, electromagnetism. So let's start. Here we will learn how electricity is used to produce magnetism, as in electromagnetism. For that, let's first learn about magnetism. You might have seen magnets. Magnets have different shapes and sizes. The shape of a horseshoe magnet is like the shoe of a horse. The cylindrical magnet has the shape of a cylinder. The ring magnet is the form of a ring. A U-shaped magnet looks like a U alphabet. The disc magnet has a circular shape. Bar magnets look like a rectangular bar. And refrigerator magnets are very popular and come in a variety of shapes and sizes. Magnets either attract or repel other magnets or magnetic materials. The space around the magnet in which a magnetic material can experience magnetic force is known as the magnetic field. Materials that can be magnetized are called magnetic materials. For example, iron, cobalt, and nickel. In the case of electricity, we have two types of charges, positive charge and negative charge. When we bring positive charge near another positive charged object, they repel each other. And when we bring a negative charge near another negatively charged object, they repel each other. When we bring a positive charge near a negative charge, they attract each other. That means like charges repel, and unlike charges attract. Similarly, magnets have two poles, the North Pole and the South Pole. When we bring the North Pole near a North Pole, they repel each other. When we bring a South Pole near a South Pole, they also repel each other. And when we bring a North Pole near a South Pole, they attract each other. So like poles repel each other, and unlike poles attract each other. Let us perform an experiment to see what happens when you bring two magnets close to each other. Take two magnets, hold the bars in your hands with their like poles facing each other. Try to bring the North Pole of one bar magnet near the North Pole of the other. You will experience a repulsive force. And then try to bring the South Pole of one bar magnet near the South Pole of the other bar magnet. Again, you will experience a repulsive force. Now flip one of the magnets lengthwise so that unlike poles face each other. In this case, you will experience the attractive force. So we conclude that like poles repel each other, and unlike poles attract each other. The phenomenon of either attracting or repelling the magnets or magnetic materials is known as magnetism. So now you know what is magnetism, and magnetic strength of a magnet is the maximum at the poles of the magnet. You can check this by bringing a horseshoe magnet near a pile of iron fillings. You'll observe more iron fillings concentrate at the poles of the horseshoe magnet. So we have learned about magnetism. Now we will learn about electromagnetism. This is the study of this electromagnetism was initiated by Hans Christian Ørsted, who accidentally found that the electric current can produce a magnetic field. In 1820, Hans Christian Ørsted was trying to show to some science students that electricity and magnetism are not related to each other. He conducted an experiment where he took a wire and passed an electric current through it. There was a magnetic compass near the wire. To his surprise, the magnetic compass needle swung towards the wire. He was intrigued. Then he turned off the electric current to see what would happen to the magnetic compass needle. Upon switching it off, he observed that the needle swung back to its original position. So Ørsted discovered that an electric current creates a strong magnetic field. This strong magnetic field was able to attract the nearby magnetic materials. so we concluded that electricity and magnetism are related to each other. For example, a battery and an iron core. A piece of iron coiled with an insulated wire is known as an iron core. When the electric supply is on, the current starts flowing in the conductor or iron core and generates a magnetic field around the wire wound on the iron piece. Hence, the iron core behaves like a magnet and produces a magnetic field around it. If we increase the voltage of the current flowing through the wire by increasing the number of batteries, the strength of the electromagnet increases. Similarly, if we decrease the voltage of the current flowing through the wire by decreasing the number of batteries, the strength of the electromagnet decreases. Strength of the electromagnet also depends upon the number of turns of wire within the coil wound around the iron. If we increase the number of turns of wire within the coil, the strength of the electromagnet increases. Whereas if we decrease the number of turns of wire within the coil wound around the iron, the strength of the electromagnet decreases. The iron core behaves like a magnet and produces magnetic fields around it. As long as the current flows in the circuit. In other words, you can say that the iron core behaves like a magnet until the circuit is closed. Such magnets that are produced with the help of moving electricity are called electromagnets. Friends, you are surrounded by numerous electromagnets in your home. Electromagnets are present in music players, telephones, doorbells, hair dryers, and electric motors. Moreover, nowadays high-speed trains known as bullet trains are being run using electromagnets. Bullet trains are not allowed to run on the track. In fact, bullet trains float above the railway track in order to increase the speed of the train. Friends, you can also make your own electromagnet at home. Here, we will learn how to do that. The materials required to make an electromagnet are insulated copper wire about 1 meter long, dry cell battery in a holder, long iron nail, uncoated paper clips, and sandpaper. Let's make an electromagnet by making use of these materials. First of all, remove the insulation from the ends of the copper wire with the help of sandpaper. Then wrap the wire tightly around an iron nail in a spiral manner. Make sure that there is enough copper wire at the end of each to connect the battery. Connect one end of the wire to one end of the terminals of the battery. Connect the other end of the wire to the terminal of the battery. Now, bring some paper clips closer to the iron nail. You will see that the iron nail attracts the paper clips. This is because of the electricity flowing in the wire that is passed into the iron nail, making it magnetic. When you disconnect the battery, then the circuit becomes incomplete. The current stops flowing through the wire. The iron nail behaves like a magnet and produces magnetic fields around it as long as the current flows in the circuit. As we have discussed earlier, the strength of an electromagnet depends upon the amount of current flowing through the wire. If we increase the amount of current flowing through the wire by changing the battery, the strength of the electromagnet increases. Whereas, if we decrease the amount of current flowing through the wire by changing the battery, the strength of the electromagnet decreases. Strength of the electromagnet also depends upon the number of turns of the wire within the coil wound around an iron. If we increase the number of turns of wire within the coil, then the strength of the electromagnet increases. Whereas, if we decrease the number of turns of a wire within the coil, then the strength of the electromagnet decreases. The iron nail behaves like a magnet and produces magnetic field around it, as long as the current flows in the circuit. So we have learned how electricity can be used to produce magnetism.
Thank you so much for watching. Don't forget to like, comment, and share this video. And if you want to see more fun videos, you can hit that subscribe button. You can also follow us on Facebook and Instagram for more content. Bye-bye!